Good morning. I am Dr. Navina Prabhushi, Professor of AC Department, Rohini College of Engineering and Technology. In today's class, we shall discuss about the topic of eclipse. So, eclipse is defined as the cutting off the light from the sun by totally or by partially. So, when the satellite is launched, it will orbit the Earth. So, whatever the satellites that may be under eclipse for certain time duration. So, the effects of eclipse and how the eclipse happens, all these things we are going to discuss today. So first of all, eclipse of satellites. So this effects of eclipse, it has a serious effects of satellites which are launched in the geostationary orbit. So first of all, geostationary orbit that will be around 36,000 kilometers from the Earth's surface, and it's a circular orbit. And the satellite which launched in that orbit will always face the same side of the satellite will faces the Earth on the side. So here the revolution is of our 24 hours. So consider the geostationary satellites which are eclipsed by the Earth uh, once each day. So every day the geosatellites will comes under the shadow of the Earth. This happens when the Earth's equatorial plane coincides with the plane of the Earth's orbit around the Sun. So the plane of the Earth's orbit around the Sun is known as the elliptic plane. So next is the equinox. So equinox means the daytime as well as nighttime both are equal. The duration of daytime and nighttime are equal. It means that day is represented as equinox. So in the year there are two equinox are there. One is represented as spring equinox, another one is the autumn equinox. So in case of spring equinox, it is the season between the winter and summer, and autumn equinox, it's the season between the summer and winter. So this is the eclipse of satellites. So first consider that the Earth is the sun is there, sun is at the center, and the Earth is revolving around the sun. So when the satellite is revolving around the Earth at certain positions, it will be get eclipsed. Means, for example, in this figure, first of all, this is the Earth, and this is the satellite. So here sun is there. When the sun, Earth, and satellites, all these things comes in the straight line, then the eclipse will arise. So in this case, first is the here this is the autumn equinox. So in this autumn equinox period, when the sun, the satellite which comes just behind the Earth, then the shadow of the Earth falls on the satellite, so it will not get direct light from the sun. So this is known as the eclipse. And here also the satellite is there, and it falls behind the Earth, and the satellite will be in eclipse. So when it is in transit, there will not be any eclipse. So during its transit time, if it falls behind the earth or the shadow of the earth falls on the eclipse, it will not get direct sunlight from the uh, solar system. So which turns into the satellite is in eclipse position. And in position A, so the satellite revolves around the earth, and here the satellite will get the direct line of sight of the sun. Okay, so so if the Earth's equator plane, which coincides with the plane of the Earth's orbital around the Sun, the geostationary satellites will be eclipsed uh, each day. So, since the equatorial plane is tilted at an angle of 23.4 degrees to the elliptical plane, this keeps the satellites in full view of the Sun for most of the day in an year. So around the spring and autumnal equinox, when the sun is crossing the equator, the satellite does pass into the Earth's shadow at certain periods. This being the these periods are considered as the eclipse period. So the spring equinox is the first day of spring, and autumnal equinox is the first day of the autumn season. So the eclipses begins 24 so 23 days before the equinox and ends in 23 days after equinox. So each day the eclipse lasts about 10 minutes at the beginning and end of the eclipse period, and increases the maximum duration of 72 minutes in a full eclipse. During this eclipse, the solar energy will not be directly fall on the satellite. So for its operation of the solar panels and various components within the satellites, it depends upon the some external power supply. That is, it receives signals from the batteries that are provided while launching. So this is the sun transit. That is a Earth is there, and it's a geostationary orbit. And if the satellite lies behind the Earth's equatorial plane, it's the eclipse period. So the sunrise falls on the Earth. That will be a satellite that will be headed by the Earth. So the satellite is launched from the east of this Earth station. Satellite enters the eclipse during daytime, and if this satellite launched is west of the Earth station, the eclipse does not occur until the Earth station is in darkness. So here, the satellite longitude is west. The eclipse period will be in the evening. Thank you.